Howdy everyone, and welcome to the Chapter 4 tutorial video where we go over some example problems from the book to make sure we have a good handle on how to do some of the problems you might see in the problem set or on a test. And so in this chapter we'll look mainly at the isotope composition and then we'll look at a problem involving atomic weight. All right, so for isotope composition, this is what the chapter was really building towards, the whole thing of all the different parts of an atom, the protons, the neutrons, electrons. Can we figure out how many there are based on some given information, whether it's a symbol or some of the numbers given and all that. And so this table is just part of problem 109, but I think 3 is enough there. But the idea is we'll use the information that they give us in this table for each row to figure out the rest of the row. A couple things to keep in mind. We are not necessarily going to solve this left to right each time. We're going to say what information do they give us and what's the next usually easiest thing to get from that until we finish the row. And so at the end of it, everything will be filled in. All right, so for the first one, they give us a symbol of Zn plus 2. And the only weird thing about this problem is they don't put the mass number in the corner. And there's a similar problem on the problem set that also the same way. When you type in the symbol, you don't type in the mass number. So in order to get the information, okay, they gave us an extra number of neutrons over here. But again, all the information you need is given. So we'll just look at that symbol. And it's Zn, so that's zinc. And we'll just go ahead and look at a periodic table. I've got one pulled up over here. And for zinc, I look in the box and I see, okay, it's atomic number 30. So Z is 30, no big deal. And the next easiest thing there is, well, the atomic number is always equal to the number of protons. So I'll just come over here and put a 30 there as well. Right. Next easiest maybe is the mass number, because that is always equal to the protons and the neutrons. Those particles are both about 1 AMU, so we just add them up. 30 plus 34 is 64. Now, one thing to watch out for here, some people get confused. This 64 is not what's on the periodic table. If you look in the zinc box, it says, I believe it's 65.39. Say, well, it's close, but it's not 65. Remember that the number in that box for the mass is an average of all the isotopes. But when we're doing these problems, we're looking at one isotope in particular. So the number should be close. And yeah, 64 close to 65. Yeah, that's good. That's a good sign. But it doesn't have to be the same number. And a lot of times it'll just be off by 1 or 2 like it is here. That's fine. This isotope is 64. The average of all isotopes is around 65. All right, so just watch out for that. Next up, now that we've got that, we just need electrons. Electrons are always the protons minus the charge, because protons are +1, electrons are -1. They'll cancel out if they have equal numbers, but here, you kind of think, oh, if I got a +2 charge, I must have 2 extra protons compared to electrons, or you just say 30 minus +2. There are 28 electrons. Either way, it works out there. All right, now for the next line. Again, I don't have a symbol. I don't know what this is right away, but 25 for the atomic number. So I know protons, automatically 25. Not the mass number, the neutrons I get from the mass number. So 55, it must be this 25 protons plus however many neutrons. So 25 plus 30. Equals my 55. For the charge, again, protons minus electrons, so 25 plus 1s, 22 minus 1s, subtract, that's a +3 charge. And so now I'll look at a periodic table and say, okay, I'm an atomic number 25, box number 25 is manganese, so Mn. And for this problem, they just want the charge in the top right corner, so I'll put a +3 there, and that's my symbol. All right. And then the last one here, again, we don't have atomic number, but we've got protons. Same thing, we just go the other way. 15 protons must be 15 atomic number. Neutrons are 16, so 16 neutrons, 15 protons, add them up. Mass number must be 31. For the charge, well, we've got 15 protons and 15 electrons, so 15 minus 15, that's a charge of 0. So when I write my symbol, I'll just look up 15, which is phosphorus, so I'll put my capital P. And with 0 charge, I don't put anything in that top right corner. All right, so that's how we do these problems. Sometimes you have positive charge, sometimes negative. Sometimes they give you a symbol, sometimes they just give you numbers. But again, use the information they give you to figure out what is it that you can get next until you get the next thing and the next thing, and then you're done. All right, next up for 99, this one is a little bit tricky when we get to the end. It does require a bit of algebra and rearrangement, but this first part's not too bad. We've got bromine with two naturally occurring isotopes, 79 and 81. The atomic mass or atomic weight is 79.904, so this is an average number. When we average these two, we get that. That's important for part B. But then we look here and say, okay, part A, if 79 is 50.69%, what's the abundance of bromine 81? All isotopes, when you add them all up, they have to equal 100%. And they've told us these are the only two, so okay, 100%, just add some decimals there. If we subtract off the 50.69%, you get a 1, we get a 3, we get a 9, we get a 4. There we go, 49.31%. Apologies for writing on a pretty severe angle there for some reason. Bromine 81. All right, so that's all you have to do there. If you're asked what's the percent, it's, well, what gets me to 100%? B is where things get a little tricky. They give us this information that, okay, now that we've got the bromine 81, it has an isotopic mass of 80.9163. Remember, the average is 79.904, and they want to say, based on that, what's this number? How heavy is the bromine 79 isotope? And so we got to set up our math where we say, okay, for the atomic weight, you take the percent abundance in decimal form, multiply it by the atomic weight of that isotope, and then add all the isotopes together, and they'll equal this atomic weight, the average. So we say, okay, first isotope, 50.69% becomes 0.5069, but that's times some amount. I'm just going to call it X. Right? And that's going to equal, well, I don't know what it's going to equal. Well, I do. It's going to be 0.5069x, right? That's what I've got. I then have the next one. So it's 0.4931 times its mass, so 80.9163 AMU. I'll go ahead and multiply that out. All right, so 0.4931 times 80.9163, and I get 39.8998. I'm going to have some extra sig figs here. That's okay. It'll work out at the end. And the rules say, well, if I add these two numbers together, it's going to equal 79.904. Right? That's these two isotopes must add up to that. Well, now I'm just going to rewrite this in a more traditional math way to solve for X. So I will say 0.5069x, let's see, plus 39.8998 is equal to 79.904. So that's exactly the same thing. I just wrote it sideways. But now I said, well, now let's get X by itself. So I'll subtract 39.8998 from each side. So this will cancel. Over here we get, what is that, 79.904 minus 39.8998. And so with sig figs, this will be 40.004. Yeah, that looks right. So that's good, AMU. And that's now equal to 0.5069x. Well, to get x by itself, we'll divide by 0.5069. We'll take this and divide by 0.5069, so that crosses out. And we will get that x equals, so 40.004 divided by 0.5069, 78 point, let's see how many sig figs. Well, it says 4 sig figs. So it would, I'm going to put 919 AMU. Technically, with 4 sig figs, it would be 78.92. That might be a one where Mastering Chemistry will tell you how many sig figs to answer, or how many decimal places. But I'm going to put that as my answer there, just to match the others. That has 4 sig figs. It would be 9189 if we went to 4 decimal places. So that's a trick there. But that's how you do it. So you just kind of say, okay, I don't know what this isotope is, but I can just make it X and then do the problem like normal. And then there's your algebra skills coming into play. Your math teacher did not lie to you. You are going to use them someday, and that day is today with problem 99, or on the problem set, problem 100. All right, so hope that was helpful, and I will see you guys later for chapter 5. Have a good day.